In the last video, we saw why power comes in three phases, three staggered voltages, adding up to smooth power on three wires. So let's get practical, because hiding in every three-phase system are actually two different voltages, and mixing them up is the single most common mistake people make. They're related by a strange-looking number, the square root of 3. Let's see where these two voltages come from, and why that root 3 keeps showing up. Picture a three-phase supply wired the most common way. A Y shaped like the letter Y. This is the connection that feeds homes and most of the grid. There's another shape, called delta, but we'll save that for its own video. Three windings meet at a common center, the neutral, and the far end of each is a line going out to the load. Now, there are two voltages you can measure. From one line back to that neutral center, you get the voltage across a single winding, the phase voltage. But between two of the outgoing lines, line to line, you get a different, bigger number, the line voltage. And here's the thing. The line voltage is always bigger by the same fixed factor, about 1.73 times the phase voltage. That number is the square root of 3. So where does it come from? So here's the golden question. Why root 3 exactly? One important thing first, this is not a simple algebra problem, because the three phases point in different directions. They're vectors, or phasors, and you have to subtract them as vectors, not just add up the numbers. Don't worry if that's new, just follow each line as it's written. We start from the standard formula for the size of the difference between two of these voltages. V line equals the square root of V phase squared plus V phase squared minus 2 times V phase times V phase times the cosine of 120 degrees. Now the key step, the cosine of 120 degrees is minus 1/2. So that last term flips to positive, and we're left with V phase squared plus V phase squared plus V phase squared. Add those up, and that's 3V phase squared, all under the root. And the square root of 3V phase squared is simply root 3 times V phase. And there it is, written out line by line. The line voltage is root 3 times the phase voltage. So here's the rule to burn in. In a Y, the line voltage is root 3 times the phase voltage. Let's use it on something you can touch. In North America, a common three-phase outlet reads 208 volts between any two lines. That's the line voltage. So what's the voltage across a single phase? Divide by root 3. 208 divided by 1.73 is 120 volts. And there it is. The ordinary 120-volt outlet in your wall is just one phase of a 208-volt three-phase system. So, two voltages, one system, phase voltage is across a winding, line to neutral. Line voltage is between two lines, and in a Y, it's root 3 times bigger because it's the difference of two phases 120 degrees apart. Keep those straight, and you'll never trip over a three-phase problem again. Next time, we put line voltage to work and answer the practical question. Exactly how much power is a three-phase system carrying? Subscribe, and I'll see you in the next one.